In this video, I'm going to talk about Windows Presentation Foundation. I'm going to talk about XAML, which is a programming language used in WPF. I'm going to talk about partial classes, which is a C# feature. And we're going to create a very, very simple graphical application. And I want to emphasize that, that in this episode and the next episode of this series, we're going to be looking at a very elementary, rudimentary look at WPF. WPF is absolutely enormous. There are dedicated courses like this one for doing professional quality, a really deep dive look at WPF. We're just going to scratch the surface here. So let's start off with what is WPF. It stands for Windows Presentation Foundation. It was originally released with .NET 3.0. And this is how Microsoft recommends that, that modern applications with graphical user interfaces be built. It is specifically designed to separate presentation concerns from business concerns. We've talked about that a fair amount in this course. And I mean, the one sort of characteristic thing about WPF is the amount of surface area that this programming system gives you is absolutely enormous. It can do 2D rendering, it can do 3D rendering, it can do scalable vector graphics, it can do traditional UI controls like buttons and drop-down lists and things like that. It can do animation. You can say, oh, I want this list to be populated with whatever information is in this database, and then it changes as the database is updated. You can do all kinds of great things with WPF. So I think the best way to get a beginner look at it is to just start creating a WPF application and see what happens. So if we go to Visual Studio and click on New WPF Application, then we'll pop open the WPF project with the designer. So let's take a look at that. So here I've said New Project, choose WPF Application. And that would bring up this project, and it would show us this designer. So let's take a quick look at what's going on here. We have here this visual designer. It's showing some guidelines and as I move the mouse and things like that. And this is the main window of our new graphical application. This is a representation of how it's going to look. Now down here, you see we have this bunch of code that looks like it's written in XML. I'm going to click this little button here. This swaps the two windows. So the designer is now on the bottom and the XML is on the top, just to make it a little bit easier to read. So we have, this says there's an XML element here called window, and it contains a sub-element called grid. And it's got a bunch of XML namespaces and stuff like that in here. Not really sure what's happening, but we'll get back to that. And then over here, we have our usual solution. We've got a bunch of stuff in here. We've got an app.xaml. We've got a mainwindow.xaml. And if we pop this thing open, then we have mainwindow.xaml.cs. And we'll come back to what this code does later. Let's go back to our designer, and we'll look at this thing. Over here, you'll notice, maybe you haven't seen this before, there's a little box off in the gutter that says Toolbox. And if we click on that, this box opens up here. If you want it to stay open, there's a little push pin right here where we can click on that. And now it will stay where we put it instead of disappearing when we move away from it. And there's all kinds of stuff in here. You can see there's borders and buttons and checkboxes. So these are all the sort of UI elements that you would typically use in a Windows-based application. Let's click and drag on button. And I'm just going to drop that here. And all of a sudden, a button has appeared here. And if we look in this XML window here, we can see that we now have a window that contains a grid. And the grid contains a button. And the button's name is button. And its content is the word button, and so on. Now, if we were to edit this here, suppose we were to say this content is hello, right? Then you'll notice in the designer, the text of the button changes. And if we click on this here, we can see over here in the little properties window that, again, we have a properties dialog here that has all kinds of information about this button. And we could similarly go in here and start editing things like the content. We could change this to goodbye. Right? And you'll notice that all of these views are kept consistent. Right? So now this XML file says that the content is goodbye. The designer says that the content is goodbye. And the properties dialog says that the content is goodbye. So a couple of times I've used the word XAML. XAML without explaining what that is. And you saw in the designer that it said XAML and on the XML side of that designer. XAML stands for Extensible Application Markup Language. The code name for WPF when it was first being designed was Avalon. It originally stood for Extensible Avalon Markup Language, but they changed it to Application when it shipped. It's a subset of XML. Obviously, it looks like it's just ordinary XML with a bunch of XML namespaces and whatnot in it. The important thing about XAML is XAML gives us a declarative style of programming. We've talked about a lot of different styles of programming in this course. We talked about procedural programming and object-oriented programming and event-driven programming. Declarative style programming is yet another style of programming. And basically, the idea of declarative programming is you don't ever want to say, do this, do this, do this, do this, do this. That's imperative style programming. So procedural programming is almost always in an imperative style, where you're saying, I want to create a variable. I want to assign a value to the variable. I want to test its value. I want to do this and do that and do that. Declarative style programming is, well, the difference was summed up by a friend of mine when I was in college as saying it's the difference between telling somebody, I want you to go into the kitchen and find the bread and put the bread in the toaster and then take the bread out of the toaster and then put jam on it, and saying to somebody, give me a sandwich, right? Or that's still actually pretty imperative because it's giving a command. You could just say sandwich, right? And a sandwich would appear. Right? So that's what declarative style programming is like. You say what you want. You don't say how to get it. You let the computer figure out how to get it. And in this particular style of declarative programming, we have an XML document. The elements of that XML document describe instances of classes. The attributes of those XML documents describe their properties. Let's go back to the designer real quick here. And so if we look at this thing, we can sort of see how this works. We have a window object, right? It has a property, which is its title. So this is an attribute in the XML. We have a grid that sort of is keeping track of where all the buttons and whatnot are inside this window. And then we have a button. So and then we have a name and the content and all of these other properties. Right? So you can think of these things as instances of classes. This is the name of the class. And then you can think about the relationships as described by the structure of the XML. Right? So this window contains this grid contains this button. So once again, we have this idea, this sort of fundamental idea to object-oriented programming, that programs are built using composition. Right? We have a window. What's it composed of? A grid. What's the grid composed of? A button. OK. So let's go back to our regular view of this thing. And you know what? I think we can probably just build this thing and run it. Let's just click on Start and see what happens. And sure enough, I'm going to make this a little bit smaller so that we can see it. We have built our main window application. And we have a nice, resizable, graphical user interface application with a button on it. We can click the button. Button click doesn't do anything because we haven't yet said what this thing is supposed to do if we click the button. But wasn't that easy? We didn't write any code at all. Right? We just said, I want a new project. I want to drag a button onto this thing and go. And a lot of WPF programming is like that. A lot of it takes place inside the visual designer, trying to tweak things to get them just the way you want them. So let's not worry about the visual designer for a little while now. Let's take a look at the code. So I'm going to stop this thing. I'm going to go back into mainwindow.xaml.cs, and we'll take a look at what's actually here. Ignore this code here. This is code that I added. We'll get back to that in a minute. What's generated for you is we have a namespace, which has unimaginatively been called video28. We have some comments here. Remember, these are XML doc comments. These are in a special format so that if you are generating documentation or the IntelliSense system uses these or whatnot. We have a public partial class called main window. It inherits from window. So you see what we're doing here is we're using the power of reusing code in the base class. The people who designed WPF made a window base class. And then when you create a new project, you automatically subclass that base class. You create a derived class from it. That window has a main window constructor. There's no main method in a WPF application the way there is in a console application. Rather, every window gets their own main code that runs when the window is created. And this does nothing except call a method called initializeComponent. So let's just put a breakpoint there. Let's start this up and see what happens. All right, so before the window has even been created, not a big surprise, the main window method gets called. If you look at the call stack down here, you can see that, holy goodness, there's a lot of stuff on this call stack. WPF is doing a ton of stuff to try to figure out how to build this window that you don't need to worry about at all before the main window method gets added. Then we call this initializeComponent method. Well, where is it? We've got this class here. There doesn't seem to be an initializeComponent method in it. Maybe it's from the base class. I don't know. Let's step into it. When we stepped into it, you'll notice how control transferred into the XAML. Right? So what this is indicating here is the stuff that was in the initializeComponent method, that is actually being generated for you automatically out of the XAML code. You don't actually get to see that. Right. However, there are some things we can do here. All right. If we say go to definition, then we seem to have popped into a window. This says main window.g.i.cs. And the G is a convention that indicates to you this is not code that was written by a human. This is code that was automatically generated by a computer. And in fact, if we go up to the top here, you'll see that there's a big comment that says, this code was generated by a tool. Do not change this code. It's going to be auto-generated for you automatically. And you see down here, again, we're in the Video 28 namespace. And again, we are in a public partial class called main window. So what's going on there? Partial classes are a feature of C# that was specifically introduced for this kind of scenario. The idea is that Visual Studio is going to generate a class for you based in part on the information that's in the XAML file, rather than make the generated code a base class and then say, well, your code, your user code that you are going to write in this WPF application, that all gets to be methods in the base class. Instead, what Visual Studio has done is has said, it's all going to be one class. We're just going to split it into two parts. I get one part, and you get the other part, and the compiler will combine them together when the program is compiled. And so that's called a partial class in C#. The machine-generated side is hidden, and we've just seen that you can click on initializeComponent. You can use go to definition, or there's a number of tools that you can use to actually go see that thing if you want. But you don't have to. All of that stuff in there is generated for you automatically. You don't have to care about how it works. Let's really briefly just take a quick look at the window class as well here. So if we hit F12, go to definition on the window class, we can see that there's a namespace, system.windows. It has a base class window. Its base class is content control. And it implements an interface, iWindowService. And then there's just a ton of stuff in here. Right? There's a bunch of static read-only fields. There's a constructor. There's all kinds of properties that say whether this window is allowed to be transparent, and all of this. There's a huge amount of information here. I'm not going to go through, well, basically any of this, except to say that there's a bunch of protected virtual methods here. And these are useful things to override. And we'll talk about overriding them in a little bit. All right, so let's sum up the code generation system here that we've seen so far. Instead of a program class that has a static main method, we have a class that inherits from window. And each window has a constructor that is going to be called when the window is created. The automatically generated class that we get has a bunch of controls on it, like the button that we added. Those will show up as properties on that class. You get to edit your half of the partial class, and that extends the Windows base class. All right, so how are we going to make something happen when we hit that button? Well, Clicking is an event that is sourced by the button class, and so your Windows class can subscribe to it. So let's take a look at that. All right, so again, let's take a step back here. We have two classes. We have the button class. It is going to source an event. The event is, I was just clicked. You might be interested in that. So it's going to source that as an event. Then we have the listener, the main window class. It would like to know when that click event happens, here's what I would like you to do about that. So let's write that code. In main window here, we can say this.button. Right? So the control has been surfaced as a field on the class that's been generated for us automatically. And then I can say, when the button click event happens, I can say plus equals. And then it says, oh, you probably want something called button click here. Press tab to insert. Right? And if you do that, then it automatically creates a new method called button click and creates it for you here. Now, I don't want it to throw new not implemented exception. Instead, what I want it to do is I want it to say, I'm going to make a label, and I'm going to change the contents of that label when the button click happens. So let's see how we're going to do that. So back here, I'm going to go to my toolbox. I'm going to grab a label. I'm going to draw that there and say, OK, this label, its content is my hello from my label. All right. And now in here, we've had a property called label created. So this is no longer red squiggly underlined. And I'm going to say goodbye from my label. And now if we run this code, we initialize, we start running the code. And if I press this button, then it says goodbye from my label. So we've seen that we can handle a button click event by just, as we did before, saying I'm going to say plus equals on the click event and automatically generate a handler, and that's all great. There are actually some more ways to do that. Let me briefly show you another way to do that. So over here, suppose I take this line of code out here, but I'm going to keep this button click here. So now the handler is no longer hooked up to the event. But if I go into the designer, if I go to the button here, if I look in the properties window, you see there's a little lightning bolt here. If I click on that lightning bolt, then it will list for me all of the events that are going to be sourced by this button. And you can see there's lots of them. Click and drag enter and drag over and all these kinds of things. Most of the time, if you're talking about a button, you don't really care if somebody's dragging something over it and dropping it. But if you really did care, you could handle events for that. So let's say that when we click, I'm going to call button.click or button underbar click. And now this code will be executed when the button is clicked. So we can start there. Get rid of that breakpoint. And once again, we can see that the click event is handled. And then the other way to do that would be if I'm going to pop the XAML up here. And if you take a look over here in the button, you can see that this says click is equal to button underbar click. And again, this XAML and this properties dialog will be kept in sync with each other. Visual Studio will make sure that they're synced up. So if you wanted to instead write the name of the handler in here, you could do that too. So there's a bunch of different ways that you can hook up XAML. There's a bunch of different ways that you can hook up WPF objects, events, to code that you've written in your C# code. All right, so that is the most basic, simple possible WPF application. We had a button, we clicked it, we made something happen when the button was clicked. How would we test this? We're not going to in this course. There is a special system called the Microsoft UI Automation System that was specifically designed for testing GUI applications like this. And I'm not going to talk about it in this course. Just rest assured that it does exist. So summing up this episode, Understanding WPF requires understanding everything that we have covered in this course. Classes, inheritance, properties, events, all of that stuff, and a lot more. The concept count involved in object-oriented programming, and specifically WPF, is absolutely enormous. You need to understand XAML and partial classes and all of that stuff. And like I said before, we have really only scratched the surface here. XAML enables developers to make very complicated, very rich data-driven applications. And you should go consult a course that is specifically designed for WPF developers if you want to learn more about that. In the next episode, we're going to make our Hangman library work with WPF. And we're going to make an application that is just barely more sophisticated than the press a button and something happens application.